All right, in this video, we're going to focus on some things that happen inside of a circle. So the first thing we're going to review is what an inscribed angle is. So in a circle, an inscribed angle is an angle formed by two chords that meet at the same point on the circle, and it'll always be half of the arc that it intercepts. So it's going to be half the arc. That's an inscribed angle. Now, we're going to focus on what happens when chords intersect. And remember that there's a real basic formula for that. If you have four different segments, you can just, if the product of the two segments along the same chord is equal to the product of the other two segments along the other chord. So that's proportional, and those equal each other always in a circle as long as they intersect. And the angle and inscribed angle is always half the arc. If you know those two things, we can focus on all the stuff inside of a circle for our test. So let's look at question 1. An inscribed angle intercepts an arc whose measure is greater than 180. Which is true about the angle? So let's visualize what this picture is talking about. You have an angle or a circle, and you have an inscribed angle that opens to an arc that is bigger than 180. So it's going to be more than half the circle. So, 180 would be like across the circle. This is going to be a little bit bigger. What is true about that angle? Well, that angle right there, take a number bigger than 180. Take, say 200, all right? If I take 200 and get the angle that inscribed angle is, I'm going to divide that arc by 2 because an inscribed angle is half of an arc. So that's going to be 100 degrees. Now look at that 100 degrees. Is 100 degrees a right angle? No, that's 90. Is it acute? No, that's acute's less than 90. So it will be obtuse because obtuse is greater than 90 degrees. So anything bigger than 180, when you divide by 2, it's going to be bigger than 90. So it's going to be an obtuse angle. It's not going to be any number between 0 and 180 because, again, it cannot be less than 90, but it's going to be obtuse because you're dividing a number bigger than 180. End of story. Next question. Okay, let's make this picture a little bit bigger. We want to know the measure of the angle ABC. Find the measure of, or we're given the measure of angle ABC. Find the measure of X. So we know ABC. Again, think about this question here in inscribed angles. Pause it and try it on your own. We know that angle is 106. But notice that this angle here opens up to the same arc. So that means that if that's 106, that's going to be half of 106. So you're just doing 106 divided by 2, and that'll be 53. All right, 53 degrees. All right, another inscribed angle question. Let's look at this one, make this picture bigger. In the circle below, what is the measure of angle WXY? So another angle that opens up to an arc down below. WXY opens up to this arc here, which we don't have the degree of. So I can't tell you what this angle is until I find the arc. So no, all arcs add to 360. So we're going to get WY by doing 360 minus 170. And then we're going to subtract 100. So 360 minus 170 minus 100. I'll subtract the 100 first. That's 260 minus 170 is going to be, looks like 90, I think. You can check that out, verify that in the calculator, but it should be 90 degrees. All right, so now that I have the arc, I know that this angle is going to be 90 degrees. But I want to know this angle, WXY, all the way over here. Well, again, it's going to be half of this arc, half of this central angle. So it's going to be 90 divided by 2. So that's going to be 45-degree angle over there, 45. All right, next question. Now we have intersecting chords. So we're going to find the length of X. Let me blow that up. I want to know what this length is. I'm given some lengths along the intersecting chords. Well, what we're going to remember is that the two lengths here, their product is the same as the two lengths here. So I can say 3x is equal to 7.2 times 4. So let's calculate that. 7.2 times 4 is 28.8. And then we're going to divide that by 3. And so you're going to get 9.6 for that length here, 9.6. So writing that out, that's going to be 3x equals 28.8. And then 28.8 divided by 3 is 9.6. Pretty cool. It's pretty simple. Multiply and divide. Let's look at the next one. So click on this picture, make it a little bit bigger. And let's see if we can get this answer. So in the diagram below, try to work this out on your own. Again, write it out, label it. Anytime you have a picture on a screen, it's always good to draw it out so you can label on there and work with that picture, because it's very nice to diagram things if you can. So we have RS is 15. I'm going to go ahead and put a 15 there. We have ST is 8, and we have SW is 10. So we want to know, what is the length of WH? Now, if you connect W and H, it's not just this from H to S, it's the whole thing across. So whatever we get for this length here, we will need to add 10 to get that answer. So let's first solve X. It's going to be 10 times X equals 15 times 8. So 10 times X equals 15 times 8. $15 times 8. 15 times 4 is 60. 60 times 2 is 120. It should be 120. Let's check that. All right, so we know that's 120. 10 times X is 120. So 10X equals 120. 120 divided by 10 is going to be 12. So X is going to be 12. But that's not your answer, okay? X is 12. WH is 12 and 10 added together because it's the whole segment. So WH is going to be 12 plus 10, which is 22. So do the whole segment in this question. All right, next question. All right, this got a diagram here. We're going to make this a little bit bigger and try to work with this. We want to find the length of X in this diagram. So X, so this has a whole lot of stuff going on. Let's focus on what we need for this particular problem. We are wanting to know what this length is. It's in the same arc as this 3. Okay, so it's going to be 3x. We know this, 3x equals. Now the other arc, we have a 4. It's kind of split up there, 4. But it's going to be multiplied by this entire length, not just the 8, not just the 7, but what represents the 8 and the 7 here. So this right here, 8 plus 7, which is 15, that's going to be the length that we plug in there. Okay, because in intersecting arcs, it's that point where they intersect that splits them up. So 4 times 15 equals 3 times x. So let's write that equation out. 3x equals 4 times 15. 4 times 15 is 60, so 3x equals 60, which means x is going to be 20. 60 divided by 3 is 20. So I know that that's going to be 20 for that length. If that's 4, if that's 3, that's 20, that's 4, that's 15. These are not drawn to scale, so don't try to think, well, that doesn't look 20. Don't worry about that. Just focus on the formula right now. All right, next question. See if you can try this one. Make this bigger again. Find the length of y. Same diagram as before, but now we want to know what is this down here So let's go to the next part of this segment. That's 14. Those are going to be the numbers we use in our equation. So it's going to be 14y equals. So when we're splitting up the other segment, this time around, we got these two together, and the 7 is going to be by itself because that point is where they intersect. So it's going to be 7 times the sum of 4 and 8, which is 12. So 7 times 12. So let's calculate that. 7 times 12 is 84. You can verify that in a calculator if you need to. And then we're going to divide that by 14. 84 divided by 14 is going to be 6. So 14y equals 84. 84 divided by 14 is 6. So y is equal to 6. So that length here, 6. All right. Last question on this review. Find the length of chord DB. So it's going to use the same formula again. This time, though, we have a little bit more to work with. And let me caution you on this one. We are also finding a combined length. So DB is all the way across that segment. So whatever we get for X, we got to plug in both, add them together. So let's start by doing the formula again. So it's 2x times x plus 1. And then we have 6 times x. So 6x will be what that equals. Now we got to need to distribute that 2x into the x plus 1. So that's going to be 2x squared plus 2x is equal to 6x. Now we don't need to worry, we don't have to deal with quadratics. We have every term here has an x. We can divide that x out, okay? Make your life easy. Divide everything by x. That way you can say 2x plus 2 equals 6. See what I'm saying? 2x plus 2 equals 6. Much easier to work with because then you can say minus 2. 2x equals 4. And then divide by 2. 4 divided by 2 is 2. Now I have x. Don't put that as your answer, okay? X is 2, which means this length here is 3. And then this length here is 4. And DB is the combined length, that 3 and that 4 added together. So it's going to be 7. All right, you have now reviewed segments inside of circle and angles inside a circle. You have one more review left, and that's talking about stuff outside the circle. So keep on working through this, and you have one more to do.